Hey everybody, welcome. So in this lesson, we'll be covering the buy and sell portion of our bot. So this is a pretty integral portion of our bot. We're going to need to be able to buy and sell tokens, meme coins. So we want to be able to do that programmatically. So that's what I'm going to teach you right now. So let me draw a little picture of what we're going to develop. We're going to have our bot here. No pretty pictures this time, sorry. And then we're going to have our RPC node. What we want to do is we want to create something called a transaction, a buy and sell transaction. Okay. They also call this a swap, token swap. So FYI, if I use token swap, don't get confused. It just means buy and sell. We're going to send a valid transaction to this RPC node, and the RPC node will go ahead and process that transaction. What we want to include in that transaction, basically, it's just three pieces of information: the token address, the amount. So this could either be the amount in SOL that you want to buy. So there would have to be some sort of quote that translates the amount of SOL to the number of tokens you can actually get with that amount of SOL. And then the slippage. Now, if you don't know what slippage is, I'll just explain it to you very quickly. So when you're placing buy and sell transactions, if this is a high in demand token, there's other people that are getting in their transactions in almost at the same time. So if their transactions come in before you, that's going to do, it's going to drive the price up or down of that token. So the slippage effectively controls how much you're willing to pay over the original amount that you agreed on in the amount that was quoted. Once we have these things, we'll go ahead and create a transaction. You can use an API to create transactions for you. You can do them. In this lesson, we're going to go ahead and use the Jupe ag API to create the transaction. The reason for this is because I want to simplify the process for you. There's a more complex way to create transactions, and I will go into that in the bonus material, but this Jupyter Ag API will allow you to create your transaction. So if you don't know what Jupyter is, it's one of the most popular aggregators for doing token swaps. So we can take a look at the website really quick. All right, so this is jupe.ag. I'm sure you've seen this before, but if you haven't, it just allows you to swap tokens, and then it has other features. You can do limit orders and things like that. So they provide an API that you can use, and it's a pretty simple to use API for creating the transaction. So we'll do that first. There's some benefits for using this Jupe aggregator. What it does is aggregates different dexes, and it creates a route for you in the transaction so that you can potentially get the best price for things. So there's benefits in using this. But in the bonus material, I'll go ahead and cover talking to the actual Raydium program directly, and also talking to the pump fund program directly, so you can get your trades in even faster, because this thing does have rate limits. So you can look at this as a placeholder for now. We're creating the infrastructure, we're creating the framework so that we can build on. So we will add the features that we want, and we can optimize everything in our bot later. All right, going back to the diagram here, the next thing we're going to want to do is we're going to take that transaction that was created off the API, and we're going to go ahead and submit that to the RPC node. That RPC node is going to submit that to validators to process. Once the validators have confirmed the transaction, it will be committed to the blockchain. So once that happens, your transaction will be confirmed. This could take upwards of 90 seconds to do. So if you have a really slow RPC node, you have about 90 seconds before this transaction expires. So if you have a really fast RPC node, it's probably going to take 1 to 2 seconds to do this. If you have a really slow, if you're using free plan RPC node, I've seen it take maybe 15 seconds. And it depends on the network congestion, how many other people are sharing your RPC node. There's all these factors that are involved with this. So just know that your transaction may not go through. we need a way to check to see if this transaction went through. So I'm going to show you how to create a mechanism to check and see whether your transaction went through. Now, there is a feature in these RPC nodes to retry your transactions if they fail. Go ahead and go over that, but I'm going to show you a better way of doing things. We want to confirm whether a transaction went through. And if it doesn't go through within the time we want to go ahead and resend our transaction through with a new quote, because the prices of the tokens change very fast. Depending on the token that you're trying to buy or sell, the price may fluctuate too much, and we may need to get a separate quote each time we resend our transactions. That's what I'm going to teach you right now. That's what this whole lesson is about. Like I said before, later we're going to go into how to talk directly to the Raydium programs. We're going to talk also to the pump fund program so that we can perform our buys and sell transactions. Stay tuned for that. So let's get into the coding. So let's start up at the top. Go to your Main.py file, and we're going to go ahead and modify this. Remember, we created our test case, enter in token address to monitor. We're going to go ahead and adjust this. Enter in token address to trade now. So this is sort of throwaway code. We're just going to be using this main to test things, but just know that this is what we're going to be starting with. We're going to stub out things from here. All right, so first thing we're going to need is that data. How much we're going to buy. We have the token address from the input already, so buy amount. Let's say we want to buy 0.001 SOL worth of these tokens that the user entered. We want to multiply this by 1 to the 9 to put that into the LAN ports. Remember I said earlier that the computers work better with LAN ports. They work faster when you put things in terms of LAN ports, so that's why I'm doing this. I put an incast around this to take out the decimal point, basically. All right, so the next thing we want to do is we want to define our slippage. And let's just say that we want to put a 5% slippage on our original amount. So that would mean that you're willing to pay 5% over what you originally agreed on. So remember, things are happening fast on the blockchain. So if you put your slippage high enough, that means your transaction is more likely to go through. So let's say we'll just use a slippage of 5% on this one. So we're going to do 5%. So it's typically you would represent 5% this way, right? 5.05. Well, let's put things in terms of integers, because like I said before, with the same thing with the LAN ports thing, putting things in terms of LAN ports, the math is faster. The computer does the math faster if things are scaled to integers. So we're going to represent this 5% as 500. If you don't understand this, it's okay. Just know that it is scaled. If you divide this number by 100, you'll get 5%. So you got your slippage at 5%. Now what do we want to do? Well, let's leverage another class for doing the actual buy, but we'll go ahead and stub out the method here. We're gonna use something called a trades manager. It doesn't exist yet. We'll create it. So let's create something called a trades manager to go ahead and do my buy. So let's pretend we have it already. Buy, and we're going to put in the user input, the token address, and then we're going to put in the buy amount, and then we're going to put in the slippage. Oops. That's it. We're going to assume that we're going to get some sort of response from the trade manager. So we're going to build that in. Every transaction that goes through the system, you'll get a transaction signature from that. So we go into SolScan. Here's the set of transactions that occurs for this particular token. If you go into here, this would be your signature. So every transaction on the blockchain will have a signature like this. So that's what we want to get. If we submit our transaction, we want to get this signature so that later on we can use that to confirm whether it was successful or not. So going back to the code, the next thing we're going to want to do is, well, we didn't really create this trades manager, so let's go ahead and initialize it up here where we do the market manager, where we did the market manager. And let's assume that we have something called trades manager, and we're going to pass in a few things. First thing we need, the trades manager will need, we're going to need to pass it our keys hash. We're going to pass it the SolanaRpcApi API because it needs that. And then we're going to go ahead and pass in the market manager also so that it can leverage market manager if it needs it, like to get certain information about that token to make the trade. So let's get into, well, let me go ahead and import it first from trades manager. This doesn't exist yet, remember, but we'll go ahead and create it in a second here. From trades manager, import trades manager. All right, first thing we need to be able to get our keys. So this is the very dangerous part of this whole thing. You don't want to share these keys with anyone, but let me just show you how to get this information. We're going to store this in an env file that we load into this. We never want to keep our keys in our code because if you're sharing your code with someone, that you don't want them to have access to your keys, right? So what you want to do is you want to create a file. This is just how I do it. There's other ways to do it, but what I do is I put it in a .env file. So let's go to our .env file. All right, so create a environment variable called payer hash. That's what this thing is. It's just a convenient place to put your environment variables so you can load them into your program. You might be asking, yeah, isn't this unsafe? Yes, it is. You don't want to put your actual payer hash in a file because if your computer gets compromised, somebody logs into your computer, they can just take this file and then basically steal your account. This is temporary, okay? We're going to be going over the security of your keys in another module, but for now, just do this to get started. Create a new account, put $1 or $2 into it just for testing, and you can use this approach safely doing that. Later on in a separate module, I'll teach you how to secure your keys. You're basically going to want to encrypt this file and load that encrypted file into your software, and you can log in with a password of some sort. Again, you don't want to store, if you have an account that has a significant amount of money, don't store your keys on your desktop. Don't store them on your computer in an unencrypted file, basically. But know that I'm doing this for this lesson just to simplify the process, and I just wanted to make that clear. Don't store your real keys in this file. Like I said before, I'm going to reiterate this again. Create an account, a new account in Phantom. Do this, put in a couple dollars so you can do some testing. That's all you really need. And then go for it that way. All right, so let me go over getting your keys hash. Well, first thing, let me show you how to create a new wallet just for your safety. So if you're starting a new project, you're following these modules, you're going to want to start off with a fresh wallet. So go ahead and go to your settings. Just click that icon there. If you're using your phone, it's pretty much the same. Just find your settings, go into security and privacy. You're going to click reset app. And then it's going to go ahead, if you click continue, it's going to go ahead and create a new account for you with a new secret phrase. So go ahead and do that. That's how you create a new wallet. Like I said, be cautious, do that. Put in a couple dollars so you can test. And when you get serious, you're going to want to encrypt your wallet keys. And like I said before, I'll show you how to do that in the future. So go to your settings. Now, to get your wallet keys, you need to go to manage accounts. Click that wallet number 3, that's for me. Click show private key. So you're gonna have to put in your password that you set up. Click next, and I don't care if you see this. This has $0 anyway. By the way, I do host a little game called Claim That Wallet. So if you're interested, go to my crypto Twitter. It's Gordon Mac. And once in a while, I'll put a few bucks into these things, and I'll share the keys, or I'll create a little game out of it where I'll share the keys. So it'll be it's pretty much a race to the finish. Somebody has to load these into their wallet and transfer the money before someone else does. So I think it's kind of fun, but anyway, I don't care if you see this right now. But what you're going to want to do now is copy this into your environment variable of pair hash, copy that in there, and then you're done. All right, now go back into main. Now we're gonna load in our keys, create something called keys hash. We're gonna call it, we're gonna use this thing called os.getInf. Pair hash. It's got to match the name that you put in your environment file. So we call it pair hash. And it's giving me a little squiggly line right there. We got to import OS to make this work. And if it still shows squiggly line, that means you didn't set up your coding environment correctly. So you can watch my video, previous video on that, on setting up your coding environment if you're getting an error there. All right, next we're gonna get that information just to be safe. Just double check that we actually loaded in a key hash. So if key hash or keys hash, and we'll go ahead and do everything under here. Go ahead and indent that so it's part of that if block, and that's it. So what we have to do now is we have to implement trades manager to do this work for doing the buy. So let's get into that. All right, so create a new file called trades manager. tradesmanager.py. Okay, we're gonna go ahead and create a class called trades manager in here, and we're gonna make this a child of threading, and we're gonna go ahead and define a constructor for this def, and we put in self, and we're gonna remember in the main we initialized it this way. This is your constructor, right? So we need to define these three things: the keys hash, SolanaRpc, and the market manager. So going back into trades manager, we're gonna have keys hash as an input. Then we're gonna have the Solana. Oh, by the way, I like to define the types here. Just makes things easier with the IDE navigating things. SolanaRpc API. Oops. And this is going to be Solana API RPC API class instance of that. And we want to load in the market manager in here. And this is going to be an instance of market manager. So we got the squiggly lines here. Well, let's fix that. All right, so let's complete our constructor. So what you're going to want to do is just copy that line that we used for all our other thread classes. Just do it. Thread dot init safe or init self. Okay. And then we're going to want to create a new variable for holding our wallet keys. I'm going to call this thing signer wallet. And what we're going to do is we're going to use that keys hash to generate something called a key pair. So this is something we can pass around to other components in our software in case we need to sign a transaction. So we're going to create a key pair, and we're going to pass in the keys hash into this thing. So just type this in, key pair dot from base 58 string, and you pass in your keys hash. So that keys hash thing that we had in our environment variable, that's basically what they call base 58 format. So it's a string that we can pass into this key pair utility that we can use to generate a wallet object that we can utilize in our software. And notice the squiggly pair doesn't know what key pair is. Well, we got to include that library. So if you followed my coding setup tutorial, you'll be fine. If you didn't, you might want to check that video and make sure your environment's set up for this. So what you're going to want is you're going to use solders library for this. So I call it solders.keyPair. You're going to want to import the key pair class. You'll still get some squiggly lines here. Don't worry about that. There's a reason for that. It's fine. But for this particular package, it's going to It's just going to show you those yellow squiggly lines. It's fine. Okay, next we're going to go ahead and get our pub key. This is your wallet address, basically. So this is what everybody uses. This is what you share to people. So we're going to call this signer pub key, and we're going to create a string out of this signer wallet. We're going to pass in signer wallet, and then what we're going to do is do a pub key. And that'll just get our public key, and then it'll cast it to a string because that we just want to use that. We might need to reference that later, our public key. And this public key is in also base 58 format. Next, you're going to want to create a new variable for your Solana API RPC so you can reference this later. So we'll just initialize that to what was passed in. And then the market manager do the same thing. We'll initialize it to what you passed in. Okay, self.market manager equals market manager. And that's it for now. The next thing we're going to want to do is we're going to define the buy and sell. Well, first of all, let's just do the buy first, and then we'll do the sell, right? So we're going to create a buy function that the client can call. So that would be our main function right now is calling this. So we could just go back in our main. Just this would be the signature for our method, our buy method. Just cut and paste that. Copy that. Go back into trades manager. Put that in there. We want user input. Well, I don't want to name it that. I want to call it something else. These are just names, so you can name them whatever you want. I'm going to call this, instead of user input, because that's what main called it, right? I'm going to call this a token address. And I'm going to add in the type here, string, buy amount. I'm saying that's an integer. And slippage, I'm going to say that's an integer as well. There's something else I'm going to add to this. I'm going to add the option to confirm the transaction. So if I add this, I want to make this optional. So what I'm going to do is default this to true. So if I put a confirm transaction equals true here, that means that the client doesn't need to pass this in if they don't want to. They could if they want to pass in false here. If they want to do a buy and not have this function confirm the transaction, then it'll just bypass that confirmation, and you'll see that later. It'll be a little more clear. So what do we want to do in our buy transaction? The first thing I think we'd want to do is grab some token info. There's a bunch of info that we need from this token, and this is why we need our market manager. So we're going to create this thing called token info and do a self.market manager. We're going to utilize market manager. Remember we created a function called get token info? Or hold on a second, we didn't create that function yet. We'll create it right now. Get token info, and we're gonna pass in our token address. So in our last module, we were able to get the price, and let me just stub this out, finish this out, and then I'll go back to creating this token info method to help us. Want to do a return, and what we're gonna do is we're going to call this function called swap that we have yet to create. So this is going to be part of this class, but it's going to be an internal function. So that's why I preface it with an underscore. So swap, and we're going to pass in token info dot sol address. And then we're going to pass in our token address and the amount, buy amount, and the slippage, and the whether we want to confirm the transaction or not. So why do we want to do this? Well, the sell has a similar case, and it's going to utilize the swap method also. So that's why I created this. We want to create a new function for doing the swap transactions because it's so similar. They're so similar to each other that they can utilize basically the same code. So let's go ahead and define this swap method to help us. So we're going to create this self, and what we're going to do is I'm not going to type all that in again. I'm going to just cut and paste this to help out. All right, so we want is the token, the Solana address. And this will become clear to you in a second why we need this information. So what we want is we want the in token address and we want the out token address. So basically your in token address is what you're swapping with. So if you're swapping with Sol, it would be Sol, the Sol address, and your out address would be what you're swapping for, and that would be your meme coin address. The buy amount, you know what that is. We'll change this to just amount, and the rest of the inputs are the same as they were in buy. So first thing we got to do, let's go to set up a return value. I usually like to do this. It's usually good practice to set up a return value for this function, since this thing is going to require some work. So we'll set that to none. That'll be our default return value. We're going to create something called a swap instruction or swap transaction, if you will. And we're going to utilize something called get swap transaction from the tokens API. So we have yet to create this. So we're going to utilize our tokens API class. Remember we created that in the last module. Tokens API, it doesn't exist yet. Let me go ahead and import it from, it's actually an import, I think. Yeah, it's just a functional thing. It's not a class, right? So what we need to do here is we got to just import tokens API as tokens API. Then we can use the functions from it. We're going to call something called get swap transaction, and we're going to go ahead and pass in our signer pub key. So basically this is your wallet address. So we're not passing in private keys or anything. We want the in token address, and then we want the out token address, and we want the amount, and we want the slippage. That will create our swap transaction. And we'll go back to this. We'll go back to the implementation of this in a second. We still also need to do the token info as well, but we'll do that. Let's just stub it out first. So the next thing we want to do is we want to make sure that this swap transaction is valid. So we'll just do an if, check if it's a valid swap transaction. We're going to make it past none if it's not a valid transaction. The next thing we want to do is we want to get the raw bytes off this transaction. So we want to basically convert this, and we'll use something called base64 to help with this. We'll do a base64 conversion. You're going to need to import base64, and this is just a library that helps you decode, encode base64 encoded formats. So we're going to utilize base64, and there's a function called encode, b64 encode this swap instruct transaction. We're going to go ahead and encode that. What encoding means is it will convert this swap transaction that was probably like JSON. It's probably going to be JSON, a JSON string. We're going to convert it into bytes. We need to do this in order to submit it to the RPC node. You don't have to understand this fully, but just understand that it's encoding it into a format that the RPC node can take, and it's bytes. And we're going to create something called a raw transaction, called raw TX. We're going to create an object called version transaction, and we're going to call a function called from bytes. So from these bytes that we just created, we're going to be able to create a transaction that we can pass to the RPC node. So we'll just put in our raw bytes, put in our raw bytes in there, and I got the squiggly lines of version transaction. I will need to import a new class called version transaction from the solders library. Copy that, solders.transaction, import version transaction. So now that I have that, I'm going to go ahead and create a sign transaction. So now we got to sign this thing, right? So I'm going to create this thing called a sign transaction. I'm going to create a version transaction, a new transaction out of it using the raw transaction. I'm going to do a dot message. This is version, that's why I got the squiggly lines on that. Oops. And I'm going to go ahead and pass in the signer wallet. We have to pass it in like this. So this version transaction accepts an array of wallet addresses. So that's what these brackets are. They're just arrays. So we just have one wallet address here. So we're just going to pass in our one wallet, signer wallet. So you can have multiple signers on a transaction, by the way, but That's why it allows you to import more than one. So by doing this, you've signed the transaction. So you can actually pass this to your RPC node now. We're going to go ahead and call a function to send this off so the RPC node can process it. I apologize if this part is a little confusing. If you don't know anything about encoding data or decoding data, it might be a little confusing, but just follow the steps. Just know that it's just encoding it into a format that the RPC node can take. So that's all this is for. Next thing we want to do is we want to make sure that this transaction is actually valid. So if we had valid keys, a key pair, and we created a good version transaction, we should be able to continue. So this is the part that is a little tricky here. So this is the part where we want to send this transaction to our RPC node. Remember I told you that some transactions may not go through. So it all depends on network congestion, how good your RPC node is, things like that. So what we want to do is we want to be able to try more than once to do it. Let's go ahead and first grab the signature. So now that we created our signed transaction, we have a signature. So remember, if you went to the SolScan website and then you see the signature of the transaction, remember I showed you that. So we're going to go ahead and get that signature so that we can use that information later to check to see if it's been confirmed by the validators. So what we're going to do is on this signed transaction, we're going to utilize something called signatures, and it's an array of signatures. We just need one. There's going to be one element in this transaction. So it's going to contain that signature. We're going to convert that to a string, and then we're going to check to see if this transaction actually happened. So let's get back to that in a second. So the next thing we're going to do is we're going to actually make the call to the RPC. We're going to actually send this transaction through. We're going to go ahead and use our API RPC. To do that, we're going to create a function called send transaction. We haven't created this yet, by the way. So you're going to go ahead and pass in your signed transaction, and that's basically it. That's the idea. So let's close out our try statement here, and we're going to just do an accept. I'm just going to do a general exception to be quick here. And we're going to go ahead and print something. So if this doesn't work, it's going to kick out and probably say, hey, it's going to give us a reason. There could be a few reasons that the transaction fails. So we're just going to print this out to the console. Failed the process. We can go ahead and print out the error. That might give us an indication of what happened. Oh, I forgot to put ASI. So these are the bones of our swap. This is basically how you do the swap. This might fail when you do the send transaction. So we need to create a mechanism to actually check if the transaction went through. But first, let's go back to and implement a few things that we need to implement. And the first thing is token info. We don't have a method of getting that. So let's go back into Market Manager. All right, going back to Market Manager, we're going to go ahead and implement a function called get token info. And this your pass itself. It belongs to this class. Token address. I'm going to make this a string, of course. And we're just going to use, let me go ahead and put in a return value as well. I like doing this. It makes things easier in the long run. And we're going to return, just going to straight up return. We got the Ray pull monitor. That basically is what we need to use to get the token info. So this is basically just a wrapper around getting the token info from Ray Pool Monitor. So that's it. I could just pass the Ray Pool Monitor to Trades Manager, but I don't want to do this. I just want to have access to Market Manager. I don't want to have to. I don't want to make it necessary for the Trades Manager to have knowledge about the Raydium tokens monitor. It's not really necessary here. So the less classes that has to keep track of, the better. The more simple we can make this spot. All right, that's good enough. All right, going back to Trades Manager, let's see what we got to do next. We're going to implement the send transaction. Remember, we were calling the Solana API RPC send transaction. This does not exist, so let's go ahead and create it. So going to our PC, we'll go ahead and just throw it down here. Call it send. Go ahead and just paste that send transaction. And we're going to go ahead and make this part of the class. So then we're going to put in a transaction. And this is going to be something called the version transaction. And we're going to add in a parameter to provide a way to try multiple times if it doesn't succeed. So this is a feature of the RPC node itself. You can give it a number and it will retry. So you give it a number and it'll attempt to retry the max number of times until the transaction actually goes through. So there's reasons not to set this max tries number to more than 0. So we'll get into that, but it'll be available if you need it. So all we're gonna do here is we're gonna return straight up. It's a very simple call. So we're gonna do a self.client, and we have not initialized this yet, but know that there is a function called send transaction, and we're going to pass in the transaction. So let me go ahead and break this down a little more. We're going to have a bytes version of the transaction. We're just going to cast it into some bytes. So we're going to pass in transaction there. We'll call it something meaningful, transaction bytes. And we're going to go ahead and pass that in there because that's what it takes. That's what the RPC node takes, is bytes. You can't pass in this object to the RPC node. And as options, we're going to specify the options parameter. We're going to do an ops equals, and we're going to do a tx ops, and we're going to go ahead and do a skip confirmation. I'll explain to you what this means in a second. We'll just type this in. Skip confirmation equals true, pre-flight commitment equals processed, and max tries equals our maximum number of tries that we set as an input. Okay, so I got squiggly lines on this. This doesn't make sense. By the way, try to ask ChatGPT to do this for you. Just try it. It will not give you what you want. Trust me. A lot of people say, "Oh, just use people on crypto Twitter. They're making these posts that they can create a bot with just ChatGPT." No, it might help, but no, you need you need some more guidance. ChatGPT hasn't been trained well enough. Maybe later, maybe a couple years or something, but it might get to that point. But right now, it won't give you the right inputs for all this stuff. Correct me if I'm wrong. Maybe Cloud works. I don't know. But as far, I've had disappointing results trying to use ChatGPT for this kind of stuff. So you need this course. All right, so let's get rid of the squiggly lines. Let's go ahead and import the version transaction. Just cut and paste that. This is coming from the solders library, solders.transaction. We're importing version transaction. Next, we need something from the Solana library. Actually, we need a bunch of stuff, right? So let me just cut and paste this stuff. I don't want to have to type it in. So these are imports from imports for the API. We want the client. We want types, tx ops, okay? And we want several commitment definitions, confirm, process, and finalize. Right now, we're just going to use the process one. So let me explain to you what this is doing first. So this command right here is sending the transaction to the RPC node. That's what's under the hood here. These options are set, and they provide instructions to the RPC node on how to handle this transaction. So the first one we set here is skip confirmation. So there's this confirmation process that goes on with the RPC node, and it will actually block. It'll do something called block until the transaction is actually confirmed. So That would mean that if the transaction took 20 seconds to confirm, you would be waiting here for 20 seconds. Your client code would not get past this point until this is completed. So we don't want that. Speed is of the essence. What we want to do is just skip that confirmation because it takes too long. So that's why I set that. And you can play around with this if you want. Set it to false, see what happens. But I'm telling you, you likely want to set this to true, so you skip that part. Because we're going to confirm it ourselves later, and there's a faster way to do it. Okay, the next thing is pre-flight commitment equals processed. So there's pre-flight checks that are done. Basically, it's going to, the RPC node will check to see if your transaction is valid. There's certain parameters in there that'll check, like do you have the right instructions in your transaction? Are they valid, etc. We're gonna go ahead and set this commitment to processed. We're gonna, if you set it to finalize, it will, I believe it'll take longer. So we want to set this pre-flight commitment to processed. I don't know if that makes sense, but basically these pre-flight checks just makes sure that your transactions are valid before you actually send them through. If you set this, if you disable this, there's a way to disable this pre-flight check. It will not check to see if your transaction is valid, and your transaction will go through to the validators. If your transaction is invalid, you will get charged a gas fee for that transaction. So if you're dealing with a bunch of transactions, or you're trading a lot per minute, whatever, it's going to cost you a lot eventually. It's going to add up. Your gas fees will add up. So it's a good idea to do this pre-flight check. And we want to do it on processed, because if you do finalize, it will take a long time. So yeah, like I said before, you can experiment with this, but it looks like process is the sweet spot here. All right, going back to Trades Manager, we should be good to go. We've implemented everything and we need to for that. So let's hit play just to make sure it compiles. So it looks like I have a problem. It's complaining about cannot import name key pair from key pair. And that's probably because I misspelled key pair. So yeah, there we go. Took that away. Sorry about that. Let me hit play again. Yeah, it's okay. So it compiled, no problem. So we're good to go. So we could potentially tie this into our main and try to run a swap transaction if we wanted to, a buy. But let's go a step further. Let's go ahead and implement our sell. I'm just gonna cut and paste the buy code because it's kind of almost the same. In a way, we really don't need two separate functions for this, but I'm keeping it like this just so it's easy to understand. So we're gonna have almost the same exact inputs. We're gonna rename this to sell amount. This sell amount is gonna be the number of tokens you want to sell, and slippage has the same meaning to it. How much are you willing to go? So let me just change that name to sell amount here, then we're done. So that's it. We could potentially run this thing, but let's go another step further. So let's go back down here where we're actually sending the transaction through. Now with this mechanism, we have no way of confirming. So we send the transaction once, basically doing this command. Now we can adjust the max tries. So if it fails, like if it gets dropped because of a network problem or whatever, this thing will actually retry. The RPC node will retry. That has nothing to do with confirmation. So we set the confirmation to skip here, remember? But if there's a network issue or something, if max tries is set to more than 0, it'll go ahead and retry that transaction. But it will still not wait for the confirmation of the transaction to occur. So just a reminder what confirmation is. It means that the transaction has been permanently added to the blockchain, has been approved by the validators. So that's what we want to do here. We want to do that part ourselves. We can put in a max tries if you want, play around with it, but I'm going to go ahead and just keep that to the default, which is 0. So I don't need to set this. And we're going to go ahead and try to confirm it. Let's go implement the code for that. Going back into the swap, down here, let's go ahead and create something called the transaction checker. We're going to equal that to a new class called transaction checker. And we're going to go ahead and pass in the Solana RPC API. And then we're going to pass in the signature of our transaction. Okay. Now, this doesn't exist yet. We're going to create it in a second. But let's go through the logic. Let's stub out the code for what we want this to do. Let's say, all right, so one more thing. We only want to do this if the client passed in confirm transaction is true. So, oops. All right, so confirm transaction. And we're going to go ahead and make this transaction checker a runnable thing. So this is going to be threaded. So we're going to go ahead and once we create this, we're going to start it. What's this going to do in the background? Well, it's going to check to see if that transaction occurred. It's going to be an event-driven process or responsibly received from the RPC node if the transaction successfully goes through. All right, next we'll put an else here. So if we don't want to confirm it, we'll just go ahead and return the signature anyway. Maybe the client will use it. Maybe it'll confirm it on its own. So let's just set the ref val that we set. Actually, let me rename this ref val. We're going to call that or initialize that to the signature. Okay, the next thing we want to do, if we're confirming the transaction, we want to wait for that transaction to process. We want to wait for that transaction to be confirmed. In order to do that, we'll use our transaction checker and we'll go ahead and call something called wait for success. And then we'll give it a timeout because there's a chance that it might not be ever confirmed. It might get lost in the sauce. So we'll set a timeout of 5 seconds there. So that's what that is, right? So if that is true, then we'll go ahead and set ref val to the signature, the transaction signature, meaning that that transaction is good. And I forgot to put in the if. Okay, there we go. So that's it, guys. For that, we need to go implement the transaction checker now. So let's go do that. So create a file called transaction checker.py, and this one's going to require a little bit of work here. We're going to create a new class called transaction checker, and it's going to be using threading. So it's going to inherit threading or thread, and we're going to need an init method. Let me just go ahead and cut and paste this. So what are we going to need in here? We're going to need our Solana RPC node. We're going to need our signature, our transaction signature, and I call it TX signature. And then we're going to need a timeout. I put a initial timeout of 35 in here, 35 seconds. Even with the slowest RPC nodes that I've used, you'll usually get a response within 35 seconds or so. If you don't, your transaction's probably lost. Probably is never going to get processed. There's no guarantee of that. There's a possibility that it could, but it's unlikely. All right, so let's go ahead and add in our imports that we need. So we need the Solana RPC API, and that's, we need threading. We need to import thread. So what do we need in here? Well, let's just do this threading.thread that we do for all of our thread classes. Let's just put that in there for now. We're going to need some variables inside this class, but we'll do that in a second. We know that we need to run something. We need code to check to see if the transaction occurred, right? So we'll go ahead and create a run method, and then we'll go ahead and do a self.time started. This is for diagnostics. So I want to test the time that we started this checker. So at the time that the client runs start on this thread, I want to get the time. This is so I can check to see how long it took. Just for diagnostics, it's good information. So I'm going to put it in here. So we don't have time, so I'm going to import time, the time library. And this time is, I believe it's just number of seconds elapsed since the 1970. It's a Unix POSIX standard. It's pretty universal everywhere. It's also called epic time. Next, we want to call this thing called async IO. this is to run code. They call it asynchronous code. So basically in English, that means we want to run some stuff in the background. So that's what they would call asynchronous code. So we don't know how long it's going to take. So we're going to have something run in the background repeatedly, checking to see if something occurred, or it'll be an event driven. It could also be an event driven process that's checking for something or waiting for something to happen. All right, so we're going to put in the work function that will do the check. I preface it with an underscore because this is an internal function that we're going to create here. So check transaction, we're going to call it, and there's no inputs, and we're missing the import for async IO. We'll go ahead and add that. Okay, now all our squiggly lines are corrected. Now we're going to forgot to initialize the Solana RPC API. Let me just grab that, just initialize it here because we're going to need it. Also the signature, we're going to need that. Call it that. Okay, timeout, we're going to need that. Call it timeout. So let's go ahead and implement our method for checking the transaction. So we're going to have this definition here, function definition for checking the transaction. It's part of this class, so I pass in self. First thing we want to do is connect to a WebSocket. So remember we did this to check the price. So we attached our WebSocket to an address. So it's kind of going to be the same thing. So we were checking price of a certain token. We were attaching ourselves to the Raydium token vault. One of the vaults for the Raydium token, right? So we're gonna, in the same way, we could actually just cut and paste that code we used. Remember, it's into Raydium tokens monitor. We could actually cut and paste this if we wanted to. We should. It'll just make life a little easier. So we need to import WebSockets here, and I'm getting an error here. There's red squiggly line, that's bad. So I need to put async on this, and I misspelled it. All right, so what we need to do now is we need to build a sub request to the Solana RPC node. So remember this. This is a Solana documentation for WebSocket methods and HTTP methods. What we want to do is we want to use the signature subscribe WebSocket method. Basically what we want to do is we need to create a WebSocket that listens on this, and we're going to go ahead and send it a request first to indicate what we want to subscribe to. And basically you just pass it this is a JSON string, very similar to what we did before. What you pass in are these parameters, and this would be the signature of the transaction. So remember in SolScan there was a signature address. That's basically what we want to pass in. So that's it. I'm going to show you how to create this and send it to the RPC node so that we can subscribe to it, and then we're going to go ahead and listen for updates. You can see that the result that you get out of this, you get a signature notification. It'll basically just tell you if it succeeded or not. That's all the information you get, is whether it succeeded. If it times out, then that means it failed. So going back to the code, we're going to create a sub request, subscription request. We're going to equal that to self. We're going to use our SolanaRpcApi API. We're going to do something called get signature request, and we're going to pass in our signature. So it's our transaction signature. Remember, we initialize that in our constructor. And this method does not exist yet. We're going to go ahead and create it, but let's go ahead and, like we did before with everything else, we'll go ahead and just stub things out. So we continue our flow here. So let's go ahead and send that out to the RPC node. Let's say we get that our JSON data request. We're going to go ahead and we're going to convert that to bytes, basically. So how do we do that? Well, we'll get the sub request. We'll assume it's JSON, a JSON string. What we can do is use the JSON library to dump it to bytes. We'll go ahead and pass in the request, and we'll go ahead and name this request bytes. I'm just breaking this down for you so that it's not too confusing. And we're going to pass in our JSON bytes here. So I could have just copied and pasted this whole thing in here, but there's just too much going on in one line, so I'll break it down for you like that. And I need to import JSON to do this. If this is successful, we should be getting a response. Let's just name it response. So just to break this down, it's going to send the request bytes. This may take some time. It's got to reach the server, the RPC node server. And if it receives a response, we can go in and catch that response by doing this response equals await. And we're going to go ahead and do a WebSocket.receive. So once we get something back, then we will go ahead and try to listen for any events that occur on this WebSocket. All right, so next we'll go ahead and let's assume we got a response, right? Let's continue here. I'm going to put a try catch block because something could go wrong here. So I'm going to create a second response. Yeah, I'm going to call this response again. So I'm not really going to do anything with this one. I'm just going to assume that once it gets past this point, I could just actually just do this, honestly. Just waiting to receive something. Actually, just to be diligent, I should just do this. If we got a response, go ahead and continue. If not, why do anything? We may want to retry to connect to the socket if something bad occurred, but it's likely that maybe you got the URI wrong or something like that. That's why it would error out. All right, so getting that response, we'll go ahead and await, and we're going to use async IO for this. We're going to go ahead and do a wait for WebSocket receive. The reason I'm doing it this way this time is because I want to put a timeout on this receive. So this is something that could wait forever. So if the transaction is never confirmed, then this thing potentially would run forever. So I want to go ahead and put a timeout on this. So I'm going to use our timeout that we set in our constructor. So that would be defaulted to 35 seconds. So this thing will actually hold on here for 35 seconds if that was set to 35. So if we do get a response here, this is going to be a little confusing. So I'm going to hold on to that response. I'm going to call it final response. And I'm going to it's going to be a JSON response. So what I'm going to do is use the JSON library to load this response. It's going to be in bytes, and I'm going to load that, and I should be getting the JSON response. That JSON result that I showed you on the Solana webpage, I'll be getting that. Now, if something bad occurs on this, it could be a number of things that happen that cause this. I'm going to do an accept here. Timeout error is something that we actually throw. So if this thing times out, it's going to throw a timeout error. So this is where we catch that. So if we get a timeout error, we're going to go ahead and just pass. And you could print out the error, I guess, if you wanted to. I guess we could do that. Timed out. So if we did get a response, then we'll actually go down here. And what I want to do right now is I want to go ahead and log the time stopped. And remember I did that here. I set time started equals time. Well, I'm going to do the same thing here. I'm going to set this to time. That'll give you the current time. What you can do later is use this to calculate the time elapsed. So basically how long it took to receive a response. It could be useful information for you, especially if you're trying to benchmark your RPC node. So that's it. That's all we want to, I think that's all we want to do here in this method. I think we're done. All right, so while we're still in this class, let's go ahead and build out the get time taken method. So this will be a convenient method that the client can use to get the time that it took to receive a response. So we'll go ahead and pass itself since it's part of this class. We'll go ahead and check to see if self.time stopped is greater than 0. And we do not have time stop defined in our constructor, so we'll need to go ahead and initialize that. Let's go ahead and initialize the time started as well. Time stopped equals 0. Just give it some initial values there. Time started equals 0. Okay. So if this is greater than 0, then we know that everything should be initialized. So we're going to go ahead and return the difference between time stopped and time started. Simple math. And And if not, let's say it's still trying to receive something, it hasn't received anything, we'll go ahead and return the time. We'll do the difference between current time, which would be actually time dot time. This will give you current time minus the time that we started. Time started. So that would mean it would be still running, and we just, maybe the client wants to check to see how long it's been. So that's it. The next thing we want to do is we want a method to check if this transaction checker succeeded. We'll go ahead and create a method for that called did succeed, and we'll pass in self, and we'll go ahead and do an if statement there with self dot if self dot final response happened, and self dot final response contains this tree of values. So remember, this is the result we're going to get, this JSON. So basically what I want to do is check this tree, check for these values in this tree. So I want to check to see if it has parameters. Under that should be result. Under that should be value. And we got an error, this will be filled out. If this is null, that means we didn't get an error. So basically I'm just going to cut and paste that into here. All right, so parameters, result, value, error, that equals to none. Then we're going to go ahead and return true. That means we're successful. Else, we'll just return false. That's it. So during this check transaction, if we get a response and the thread will stop running, right? And we're just going to initialize. That's why we initialize final response, so that the client can go ahead and take action when that response is received. So the client can check did succeed to see if it actually finished. All right, we want another method here to allow the client to wait for a response. There's another way to do this, but I don't want to go into that. We can use pub and sub, where if it receives a response, it publishes that to the client so that it can do something, take action. But I'm gonna go ahead and just do it this way, where I'm gonna provide a method for the client to call. So I'm gonna call it wait for success, and I'm gonna go ahead and pass in self, and I'm gonna add in a timeout. And what I'm gonna do is I'm going to, in my constructor, I'm gonna create this variable called an event. I'm gonna call it self.stop event, and I'm going to use threading for this. This is a little utility provided by, or class called event. That's part of the threading library. Event, create a new event, and what it's going to do, it's going to wait until this event. It's going to wait until this event is set, basically. So we want to go ahead and set a timeout on that to the input timeout here. So that's just going to be some number. Let me go ahead and add a tag for that. So an integer. And then we're going to go ahead and just return if it did succeed. So if it timed out, it's not obviously it's going to pass back false. And I need to put a self on that. Okay. Now we don't have this. Nobody is setting the stop event. We need to set this over here. So when we finish, we get a response, we're going to go ahead and set this event, stop event. All you have to do at the end of this check transaction is go ahead and set it. So this is an event-driven system where when this gets set, this will get tripped. This will stop waiting, and then basically everything should be initialized if it got a response. So it'll call did succeed, and that would return true if the response went through before this stop event was set. So I hope that makes sense. So with that, I think we're done here. We can go back into our trades manager, finish that off. So now that we built our transaction manager, we're gonna have to add it. So let's go ahead and do a from transaction checker, import transaction checker. And hey, so I think we're okay now. We kind of stubbed everything out. I think things are okay. Well, one thing I forgot to do here is at the end of this whole thing is return. We want to return the rep val. Yeah, let's go ahead and just return this at the end. Ret val. And we could potentially run this. So let me just play this so I can make sure it compiles. And it looks okay. All right, so you know what? We forgot to do something, or I forgot to do something. Going back up here, remember we're creating the swap transaction right here. We're using the tokens API to get that transaction. Well, we didn't implement that yet, so we got to go do that. So let's go to tokens API. Let me go and just copy this whole signature here. That's what I call it, a signature. All right, go to your tokens API. We're going to go and define this function or method, get swap transaction, right? And we're going to pass in these inputs, signer pub key, that's fine. It's going to be string. The in token address, that's going to be string. The out token address, that's going to be string. The amount, we'll make that an integer. Slippage, we'll make that an integer. All right, so now we're ready to get started. So the first thing you want to do, we want to initialize the quote URI for Jupyter. So remember we're using the Jupyter API for this. So let's go ahead and initialize the Jupyter API. I'm just going to copy this in. It's a lot. So it's just the HTTP method basically for getting the quote for the token we're interested in. Let me go ahead and take you to the swap API documentation. So if you go to this site, station.jupe.ag/docs/API/swap-API. This will give you all the information you need to know. This has a large community behind it. Jupyter is pretty trusted. So what it's going to do is it's going to actually create the route for our swap. So basically what we need, this gives you all the instructions for doing this. We could actually pass this into our address bar and actually have it execute. So I got a sample. So this means that the input method is sol. We're swapping sol for this token address for this token. And then I'm providing the amount in sol that we want to buy and then the slippage amount. So we enter that in, we get this. So it's just JSON again. You're used to that now. So it provides you a quote of how much of that token you can get, basically. It gives you all the route plan for it. So it's going to use a Raydium CLMM. It's also going to use another DEX called Rollpool. So yeah, that's sort of why I like Jupyter. It provides you a good route for this thing. So this thing will work pretty good right now. Now, later on in the bonus material, I'll go over how to do it a different way, how to talk to the Raydium AMM directly. We'll also deal with pump fund tokens as well. So you'll have to learn how to talk to the pump fund program. But Jupyter is pretty good. It'll give you the best route. One downside to it is that you're using the Jupyter API server for doing this. So there is a rate limit to using this thing. I believe I'll have to look it up, but I think it's 300 calls per minute that's allowed. If you hit the rate limit, you can actually host the Jupyter Swap API yourself. So you can download, it's open source. You can actually load the code into your server and run it on your own server, and you can call it as many times as you want. You can do it that way. So I will not be covering that. I may be covering that in bonus material if you want me to, but that's the gist there. So let's continue here. So we're gonna get our quote. So here's the theory behind it. We'll get our quote, and then we'll call another method to create the transaction for us. So we're gonna pass in our quote into something called the swap transaction method, and we'll go ahead and grab the transaction, and it'll be in JSON format as well. We will use that to send to our RPC node so that we can perform the swap. All right, so going back here, so I created that command. I need to get the inputs right. Input min, we're gonna call that in token address. Output min, out token address. The amount is going to be what we passed in, and the slippage is going to be what we passed in. So let's go ahead and get our quote. So what we're going to do is we're going to call this quote, and we're going to call a method that we've already created called getRequest. It's a convenience method, and we're just going to pass in our quote Jupe URI. And if we get a response back, if we get the quote back, if we get something back, we're going to go ahead and process that. If we got nothing back, if it returned none, then we just won't do anything. So we got to create another. So assuming we got a good quote, we're going to create a swap Jupe URI. So this is the second URI for actually getting the swap transaction. So I'm just going to copy this URI HTTPS. You can find all these URIs at the Jupyter.ag website. And yeah, they probably, this is version 6. So you'll want to grab the latest one. If the signatures changed to those methods, you may have to adjust these. Just FYI. Software maintenance never ends. You'll have to update things if you want to update to the latest and greatest. All right, so we're gonna create our body here, and what we want here, I'm just gonna cut and paste this. And this is all documented on the Jupe API site that I just showed you. What you want here is you want a body to this thing, and I could just show you really quick on the site what it is. So on the swap, we got a body. This basically provides your body parameters. So you got a quote response, public pub key. Do we want to wrap and unwrap sol? Yeah, we want to set that to true. So basically I've recreated that here. So we got our body, which is just essentially what this is. It's a dictionary that provides name values. So we got our quote response, and we're going to pass in a quote that we just got. Remember, we created the request for that, and we got a quote. We'll pass that in. Wallet address, that would be our signer pub key. Put that in there, and then do we want to wrap and unwrap sol? Sure, go ahead. All right, so now we're going to go ahead and make the response request, or we're going to make a request and send this through. So we're going to use requests, and we're going to go ahead and do a post on this using this command. And we're going to pass in our swap Jupe _ URI. Oh, by the way, another thing we need is headers, and that's also in the API documentation. We need something called headers, and I'll just cut and paste this. Okay, just call that headers. And we're going to pass this into the post command. Headers equals, we'll call it headers. And the data parameter of this function we'll call create bytes. We'll call this data. Data equals JSON.dumps. Remember, we did this before. This will, if you dump the JSON, the JSON format, this will create basically, if you call dumps, it'll create a JSON data set for you. So we don't have JSON included in here, so let's go ahead and import that. So just a little correction here. This dump command, it actually creates the JSON string for you. It'll convert this this is a dictionary. They call it name. Remember I said this is a name value pair thing. Well, this will take that dictionary and it will convert it to just a logical string for you. So that is what you need to put in the post command. So that data, we'll just so it's clear, JSON data, and we'll go ahead and pass that in, that JSON data. Okay. But once we get the response from that, we'll go ahead and check to see if we got a response first of all, and then we'll go ahead and return. Okay. We'll go ahead and create a JSON out of it. Response equals response.json. If you do that, it'll convert it to a JSON object, or basically a JSON dictionary. So we'll go ahead and return. If this is a valid response, we should be able to grab something in it called the swap transaction itself. We'll go ahead and return this JSON response, and we're gonna go ahead and pass it this swap transaction. That's the response. So we're done here. So you might want to do a unit test in here just to make sure that it works. That would be ideal to do. You could do that, run your unit tests in here. Just a quick unit test, but for speed's sake, let's just assume that this works okay. So I think we got what we need. What we can do now is we can tie everything together in main. So we had left off on the buy. We actually can try to run this right now. And I'll assure you right now that if we try to run this right now, we probably will have some issues. So I'm going to be troubleshooting a little bit to get this to work. And this is an important step for you to learn. Things don't work typically straight away. So you're going to have to do this type of troubleshooting. So I did this in my last module, and it kind of shows you the ropes of how to troubleshoot your code. So yeah, let's start off here with the buy. We can actually just start testing now. And one thing I do want to do, since this buy actually will, if we go to the definition of it, it'll actually return the signature. If it was successful, it'll go ahead and return the signature of the transaction for me. So let me go ahead and do that. And I'll go ahead and set a breakpoint here so that I can check to see if it got a signature or not. And then we can go and check it manually in SolScan just to make sure that it went through. All right, I got one error in the code, probably going to be one of many. So if I try to run this, I get an assertion error. Well, this constructor is not defined correctly. You got to define this init correctly with the correct name. So it's init underscore underscore init underscore underscore. So now it's yellow again, and Visual Studio Code will kind of give you an indication that that's wrong. So we got another problem here. So when I do the buy, if you look inside the buy method, it's getting the token info from the market manager, but the market manager is returning none for this token. And that is because it hasn't been initialized. And if we go to the token info thing, it's getting it from the rate pool monitor. So that won't work because we never, if you go back to main, we haven't monitored it yet. So we're actually performing the buy before we monitor the token. So I don't want to be dependent on monitoring the token. We shouldn't have to do that. So on the buy, when we try to get the token info, let's go to the get token info and fix that. So let's go ahead and initialize token info here. Or we'll just call it rat val equals. We'll try to get it out of the monitor if we can. That's ideal. So if we get something, all right, cool. We'll go ahead and check it. If we got something, ret val. Or actually, we'll say if we didn't get anything, we got none, then let's go ahead and do it the old-fashioned way and request it from the tokens API, like we did with get price. So we'll say ret val equals this. And remember, we're only working with Raydium tokens right now, so this will only work with Raydium tokens. We'll have to put some logic in here later to differentiate between other AMMs. Like if we're utilizing pump fund, or you want to integrate some other one like Orca or whatever, you'll have to figure out which one, which API call to make. But we can work on that logic in the bonus material. So this should work. So I should be able to debug now through this, and I'll go ahead and do that. So I shouldn't need this call anymore. I'm just gonna comment this one out. This await market manager monitoring the token. We don't want that. We don't really need that right now for what we're trying to do. Let me go ahead and put in a token. Narwhal is big right now. So let's go ahead and put an address for that. All right, so I'm going to step into the function. I'm gonna see if we get a good token info. Let's see if we got anything. Yeah, we got something. We got an initialized token info here. So we can go ahead and pass that into the swap and see if that works. And we got another error. No attribute called sol address. So yeah, we don't have a variable called sol address inside token info. So let's go ahead and create that. The sol address is just the token address for sol. The reason we need that is because sometimes these vaults have wrap sol in them, so they have a different, slightly different address than a regular sol address, if that makes sense. So we'll get that information somehow. So let's go ahead and add that. We do need that. So basically we want the sol address for the vault, I guess you could say. So down here, let's see, we got this defined in here. We're gonna go down to, remember we worked on this part, getting the AMM token. All right, so let's make some changes here just to make things easier on us. So we have this min address A defined here. I want to change that. I want to take that out. I don't want to go down that deep. So I'm taking that address out and I'm going to call this, I'm going to press F2 and rename this to min address. I'm going to just call it min A. All right, so I got to change this to address because that's what it was before. And I'm going to create one for min B as well because I wasn't really needing that information before, but now I do. So min B, and we're going to go ahead and B. This is going to give you the tree of information under mint B. So if you go back to the JSON format, if you go back to that token API provided by Raydium, you can go through module 3 if you don't understand what this means. But I'm getting the tree of data for mint A and B for this. And if mint A is the token that we're looking for, then that means the vault A belongs to this token. So if that happens, we know that mint B is the sol vault address, right? So what we're going to do here is we're going to get our token info and we're going to initialize sol address to mint B's address. So what is this address? It's just a sol address. So just like the token has an address, sol also has an address. So I can show you an example of what the sol address is. Like I said before, the reason why we need this is because it might be unwrapped. It might be the unwrapped sol address. So we need to know that. We need to know what we're swapping for, right? Are we swapping unwrapped sol for a token? Are we swapping a token for unwrapped sol? That's why we need to know that. So if mint A is not the token vault, it's the sol, it must be the sol vault. So we're gonna do the same thing, but we're gonna say that we're gonna go ahead and initialize the sol address to the mint A address. Okay, pretty simple. While we're here, I'm gonna go ahead and initialize something called token decimals. You don't really have to understand this right now, but so it's just the fractional bit part of the token. So how many decimal places can you go basically for breaking up the token amounts? So I'm just gonna initialize that here. So that is something that is provided by the mint A. So if mint A is our token, then we'll go ahead and initialize that and to mint A decimals. And we'll do this if it's the other way around, we'll initialize it to the mint B tokens, mint B decimals. And we don't have a variable called token decimals here. And we'll need this later. I'm just doing this while we're in here, so we don't have to go back to this. So I'm just gonna call it token decimals and just initialize it to nothing there. So now we're good. We should be good. So now we can go back to main and try to rerun this thing. Let's go ahead and debug. Step through it. Right. Step in there. Okay. I got my token info. Just make sure that's okay. So this is the sol address. See, it initialized it. Sol 111. Are those? Yeah, those are all. I think those are all ones. SO 1111111, and then it ends with 2. So that means it's unwrapped sol if it ends with 2. I believe just the regular sol address ends with 1. See that? See what I mean? But that's all it is. And let's see if I can actually get into the swap. Okay, this is the big moment here. Will it actually work? All right, looks like I got something. That's good. I got something. So now I'm gonna do the base 64 encode here. Oh no. bytes like object is required. Let me see what I did wrong here. All right, so simple mistake. We don't want to encode, we want to decode. So it's basic support decode. Sorry about that. All right, let's rerun that. And token, we're going to play that through. And okay, so we're back to where we were. All right, there we go. We got our bytes. Run that through. Create our signed transaction. Looks like we're okay. Let's see, we got a signature. There, that's our signature. And we're gonna go and try to send that on. And looks like we got an exception. And we can look at E to see what's going on. SolanaRpcApi object has no attribute client. Oh, well, okay. Well, that's a problem. So let's go to our send transaction. And we're using this client, and we probably didn't initialize it. So probably the step I forgot. It's okay. It's never perfect. So what we want to do here is we want to initialize something called the client. So this isn't the only way to do this, but this is just very convenient. So we're going to utilize a library called, it's part of the Solana library. And I think we included it in our imports before. We just didn't use it. So it's a class called client. We're going to utilize it. I think that's all that was wrong. So we can try to rerun it. Let's try that again. Got to put in the token address. Go ahead and send. Still got an exception. Of course. TX op is not defined. All right. Now let's go back and send transaction. Why isn't it defined? Well, it's probably misspelled. TX ops, I believe. That's what it is. Sorry about that. Okay, let's rerun. Send it. Still got an exception. Got an unexpected keyword argument, max tries. So that's probably incorrect. Let's go in here. This is probably not a valid parameter name. So this is part of the solders library, I believe. So I went into the definition of it, and this once you dive into it. So let me show you. So TX ops, if I go to definition, it'll show you the class, and this shows you all the valid parameters for this class, valid inputs. So max retries, I got that wrong. It's max retries, not tries. Okay. So again, we're getting there. And let me go grab the address, send it. All right, got another exception. Bytes object has no attribute recent block cache. Okay, well, I'll take note of that. So the problem is in the send, obviously. Yeah, so here's what I did wrong. So this has a function called send transaction, and it also has a function called send raw transaction. What I want to do is send the raw transaction since I have the bytes for this transaction. Copy in my token address. All right, step through. And let me go and step into that. Send raw transaction. Let's see if it does it. It looks like it did it. So whether it was successful or not, we don't know. So we're starting our transaction checker. It might have been too late because it. All right, so we have an issue here. SolanaRpcApi has no object, no attribute get signature request. Fix that. Thought we created that, but we did not. I'm sorry. Yeah, so let's go back to SolanaRpc. We're gonna create our signature request. for this. Remember we went to the Solana pages. We're doing the signature subscribe. You gotta pass in this stuff. So basically we want to create this. I forgot to do that. So this is pretty simple code. It's similar to this one. We did the get account subscribe request. We're just gonna create another one. Okay. We'll just create another one called get signature request, and then it's going to have that same information. So what we're going to pass in is the signature of the transaction, and it's going to have basically the same, almost the same stuff as the account subscribe request, but so it's a slightly different. The commitment level is confirmed. We want that. Once the transaction becomes confirmed on the blockchain, then we want to get notification of it. So this is how you create the subscription request. And it's returning just a dictionary of these values. So that's all it is. So we can rerun, and hopefully, let me set my breakpoints though, because I want to make sure that it doesn't succeed before while I'm debugging, you know. So I want to make sure that I have my breakpoint somewhere over here. Like, how about over here? So now that I know that it can send the transaction through, how about I just put my breakpoint down here. Okay. All right. I'm gonna start. Oops. All right. So what did I get out of it? I got nothing. So it's probably because I didn't wait long enough. So I can check my wallet. You can actually check your wallet, and your wallet will update in real time. There'll probably be a little bit of lag there, but if it does go through, you can check your wallet. I'm gonna check mine. So it did not go through. My wallet didn't change, so I think I know why. And I've been expecting this, and I wanted to address this when the time was right, because I didn't want to confuse you guys early on. So in the buy, if we go down to the swap, we're doing everything right. We're sending the transaction through. However, like I said before, your transaction may not go through the first time, may not go through the second time. So what we have to do is we have to spam the RPC node. We have to retry. So we'll go ahead and check to see if we were successful, and then time out 5 seconds later. If we were not successful, then we're gonna go ahead and loop back and try again. And I'm gonna go ahead and set a fixed number of tries here. So I'm gonna go ahead and set a variable called c_default swap tries. I'm gonna set it to 5. So we're gonna try to do this 5 times until it goes through. So once it goes through, then it's going to stop. So how do we do this? We'll just adjust our code a little bit. So on this part from before you send, we want to do a for loop for I in range of the variable we just created, c default swap tries. By the way, this is a global variable, so this is something that can be accessed by anything outside of Trades Manager. So it doesn't belong to Trades Manager per se, it's just in this file. So we're gonna go, typically you want this stuff in like a config file of some sort. So if you want it to be configurable, you put it in a configuration file and then you load it when you start your app. What I want to do here is print. I just want some diagnostics here. So I'm gonna print which try this was, number, and then I'm gonna cast the I as a number. I want to cast it as just it's gonna start at 0, and it's gonna go from 0 to the default swap tries. We want to print it out with a +1, so I don't want the index to be 0. So we're gonna put all this stuff under it. Okay, that's you have to do that indent to make sure that it's under this for block. And we're gonna do this. We're gonna see if we want to confirm the transaction, and we will go ahead and spam the RPC node, if you will. Now, if we do get a confirmed transaction, for this we don't have to create multiple transaction checkers, I wouldn't recommend that. So let's move this out of here. We don't want that in the for loop. We're gonna put this in here outside of that. Okay. So if we don't want to do this really if we're not confirming the transaction. So we'll add in another check here to check to see if this is a confirmed. The client requires this to be confirmed. So that's that. So if we do get a confirmed transaction, then we're gonna go ahead and stop the loop, and we can do that by calling break. And if we're not confirming the transaction, we actually don't want to run this. We don't want to spam the RPC, so we'll just call it once. If confirmation isn't required, then we'll go ahead and just leave it at that. Alternatively, maybe we could, yeah, maybe it might be a good idea to spam it anyway if you're not confirmed. It's just a design choice. So I'll go ahead and do that. That sounds better to me. So if it's not a confirmed transaction, I'm going to go ahead and set the signature to repval. If we're not trying to confirm it, we'll just assume that it went through, and we'll spam the RPC the number of times that we want. There may be a number of reasons why you want to do it that way, so that's why I make that an option. But this should work. So we're gonna wait. If it doesn't go through, then it's gonna continue looping. If it does go through, then we're good. Now I can condense this thing. I could put this all on one line. If confirmed transaction and transaction checker detects a success, and we'll go in and do that. It's a little cleaner. So let's try to run this again, and I will watch my wallet. In a second, I'm going to create a mechanism to check the transaction on the chain and to parse it so we can determine how many tokens we bought. So we'll do that in a second, and it's a lot more efficient than trying to check your wallet to see if it occurred or not. But step by step. All right, so now I'm debugging. It's on try 1. It's waiting now. Try 2, didn't go through. Try 3, it's not going through. Try 4, yeah, it failed the process. And I got a message, node is behind 9 slots. That means that's an RPC node issue. That's not a good sign. You might want to reach out to your RPC node provider and ask them, what's going on. You might want to switch RPC providers, etc. Or if you're hosting your own node, you might want to do some admin work on that. See, that it's vital to have a really good RPC node, but this is not acceptable. So it's probably because I'm on the free plan. So notice how I have my Helios API key right here. I don't want to share that with you. I'm gonna put in my real one actually. So I'm going to be reading that out of the env file. So I got a variable in my env file. Remember we read our key hash from there? Well, I put in my URIs inside there. I recommend you do the same thing. So they're semi-private. So let me go ahead and run this now. Let me see if I get the same issue now that I'm running with a better RPC node. All right, we'll see. Cross your fingers. Try 1, try 2, try 3. Nope. So I'm gonna check my wallet just in case. So sometimes it'll go through. So that did not work. Let me go and run it again. Try 1, try 2. All right. Well, now I got another error. It looks like, so this is not good. This is making my RPC node look bad. So this is Helios that I'm using right now. So the node is 11 slots behind. That is not a good thing. That's probably the issue. So what I need to do is I need to just switch RPC nodes. So I'll be back. All right, guys, just a couple of things. It was the RPC node. There's just something wrong with Helios right now. So I used a different one. I used Shift. That one seems to be working okay. I made some mods to Main to retry the buy if it does not succeed the first time. So what I'm checking for is the signature. If I get a signature, if I don't get a signature, then I will go ahead and set this to true. If I set this to true in this while loop, then I will kick out of this loop. So it'll keep on trying basically until it succeeds. So I made that mod. The other mod I made was in the swap itself. So what I want to do in here is I want to go ahead and on the exception, I want to check to make sure that this isn't true. So I'm going to repeat this. I'm going to check to see if we're confirming the transaction, and we are waiting for success. I'm going to check to see, I'm going to wait 5 seconds to make sure that this isn't actually successful. Because what happened is I tried to resend the transaction again and I got this error. The transaction simulation failed. This transaction has already been processed. So that tells me that I should have gotten a response. So I'm going to go ahead and, in that case, if I got to the exception, I should check it right here. So if that's the case, I'll go ahead and set the red val to signature. I know this seems a little redundant, but it seems to be the best way to try to deal with this. So I'll try to clean up the code, but for now, we'll just test this to make sure it works. So it's going to try 2, 3. Yeah, so this would never happen with a good RPC node. It would just go through immediately. So it looks like I received a response. I'm going to print that out. And that is actually a good response there. That means that it actually worked. Yep. Anyways, it looks like it worked. We got some little errors here, little kinks to work out, but it looks like the transaction worked. I just checked my wallet. It looks like it went through. So it worked. So the next thing that we're going to do is we're going to test the sell feature of this. So what I'm going to do is I'm going to buy a certain amount of the token, and then I'm going to figure out how many of those tokens I bought. So we're going to have to read the transaction off the blockchain. So once we confirm that we've sent the transaction through, it's been confirmed, then we want to go ahead and get that transaction off the chain and parse it and figure out how many tokens we actually bought. I'm just going to grab the transaction based on the signature that we got here, and I am going to read that transaction off the chain and parse that information out of here. So once I parse that information out of here, once I figure out how many tokens we actually bought, because of slippage and all that, it might not be exactly what was quoted. So I'm going to just sell that back once I figure that out. So let's do that. So first, let me just show you the transaction that went through. So this is the signature of that transaction, and let's see, it shows the swap that occurred. I was using the Jupyter aggregator to do that with 5% slippage. It gives you all that info. So what we're going to try to do is we're going to parse this transaction. So it's basically what SolScan is doing. It's parsing this transaction off of the chain and displaying it in a readable format. So it provides a lot of useful information like the SOL balance change, your token balance change, etc. So let's go ahead and code that. All right, so let's go ahead and create something called transaction info in our main, and let's equal that to, we're gonna use the market manager to get this information. We're gonna call a function called get swap info. So assuming that everything is on the chain now, we know that this transaction went through if it goes into this block. So we're going to go ahead and utilize this function to help get that information off the chain. We don't want to use Trades Manager for that because it has nothing to do with Trades Manager anymore. This is more of a market data type of thing, so we're going to utilize Market Manager. So I'm going to pass in, obviously, we want the signature, the transaction signature, and then on top of that, we want the signer pub key. So we got Trades Manager initialize that from our keys hash, so we're going to get that from our Trades Manager because it knows what the pub key is. That's just our wallet address. And then we're going to give it a number of tries. All right, so even though you're in here, you know that your transaction was successful, that doesn't mean that it's available on the chain yet. So it takes a little while for things to get picked up. So we're going to need to pull the chain, the blockchain for this information. So I set it to 40 times, and we're going to go ahead, and if we get something out of this, we're going to go ahead and try to parse it. So if we do get a transaction info out of this, this is an operation that might take a while. Like I said, it takes a little while for the RPC node to actually realize the change on the blockchain, to see this transaction on the blockchain. There's various reasons for that, but the quality of RPC node matters. The better the RPC node, the faster it'll pick it up. So what we want to do here is we're going to go ahead and just print out the swap info, and we're going to write these functions. We're just stubbing things out here. Swap info. Okay. Let's just do this part first, and then we'll deal with the selling part afterward. Let's just make this stuff work. So first thing, we got to create this thing called get swap info. How are we going to do that? Well, we'll go to market manager, and we'll create a new function called get swap info. We're going to have to pass in, this is part of the class, so we have to put self as the first input. The transaction signature, that's going to be a string. This signer pub key, we'll just keep it with that name. We're going to call it a string, and then this input right here is the number of tries. Max, we'll just call it max tries. That's what we've been using for other things like that. And max tries is an int. So to start this off, we're going to do a for loop for I in range max tries. So this is going to repeatedly check to see that transaction is on chain. So we want to create something called, under here we'll create a transaction to get. So we'll do a self.solana. All right, so we need to make a mod here. We did not initialize SolanaRpc. We set it in the constructor here, but we never created a variable for it. So we'll go ahead and do that. Self.solana. I'll just give it the same name. How about that? PC. There we go. So now we can use it. We'll use SolanaRpc, and we're gonna create a function called get transaction. There's a lot of bouncing around here. We're gonna utilize our SolanaRpc. I just wanted to make sure that we separate responsibilities out where it makes sense. So it's got a function called get transaction, and we're going to go ahead and pass in our signature. So we'll get some JSON data out of that. We'll get basically what SolScan gets. So it'll go ahead and parse that information. We'll go ahead and parse that information and try to make sense of it. So if we did get something from the SolanaRpc, we're going to go ahead and try to parse it. I'm going to create something else called transaction info, and I'm going to equal that to self.SolanaRpcApi parse. We're going to utilize a helper function in there called parse swap transaction, and this is going to create a useful object for us with the information we want. So I'm passing in not the pay address, the signer and the transaction. Why do we have to pass in signer pub key? Well, I just want an easy way to pull out that information. I want to make sure that I parse the signer keys, sol balance change, token balance change, etc. It just makes things easier when you pass that in. So since that's information that we know about, that is why we're using that. Okay, so you want to return the transaction info if that was successful. All right, so if we didn't get a transaction, then we're just going to sleep. We're going to keep on trying every second. So check your rate limits on your RPC. So this will cost you credits every time you do this. Every time you check the blockchain, you make this RPC call. So I'm only doing it once a second here, not a big deal. Even the free plans will give you enough credits to do that for a while. So we're going to import time, get rid of the squiggly lines there. Okay, so we should be able to call this, no problem. The next thing we got to do is we got to go into the SolanaRpcApi. Let's do that. And we're going to implement this function. I misspelled this, get transaction. and parse swap transaction. We're going to implement those two things. Let's go in there right now. All right, so now that we're in SolanaRpcApi, we're going to just create a function called get transaction. It's going to be pretty simple. It's got one input, it's transaction signature. It's part of this class, so it's also got to put in self there. So this one's really simple. We're just going to utilize our generic method for making the RPC call. So we're going to do a self from our RPC method, and we're going to pass in the method name, which is get transaction. You can go to the Solana API docs to find this information, but just know that this is how you do it. It's got parameters that we want to put in there. So it's an array, and inside of that array is we want to put in our transaction signature that we're looking for. And then I'm just going to cut and paste this stuff. You can get this information, like I said, off the API. I'm just cutting and pasting it. It's just needed. So that's that. So I'm just saying that we want the encoding of the response to be the JSON format, and then the maximum supported transaction version should be at least 0. You don't have to worry about the meaning of that. Just leave it like that. And so if we get a response, there should be something under the response JSON called result. So we're going to return the result. Gives us all the information about this transaction. Really quick, let me go to the Solana methods website. I'll just go and do a little search for it. So just so you know where to go. So get transaction, we'll look for get transaction. It's right here. This is where I got that information on how to format this. So that's your method name. This is what we'll get. This is the type of response we'll get, and this will give us all information about that transaction: post balances, pre-balances, account keys. There's a lot of good information here. You have to know what you're looking for. You have to know, like, a lot of this stuff is arrayed, so you have to know what this number is associated tied to. So it's a little bit of work to try to correlate everything, but it's just how it is. And I'm gonna show you that part. We're gonna create something to parse that information, and we're leaving it in this class because it kind of makes sense, because SolanaRpcApi is producing this information, so it should provide some tools to parse it as well. So we're gonna create a new method called, I'm gonna just copy in the signature here, parse swap transaction, and I'm passing in something called the owner address. Like, that's really just the payer address, and I'm gonna go ahead and create something called accounts to hold all the account information. So based on the let me give these some types here. The owner address is string. Transaction data, I think it'll pass back the dictionary, and you'll see how I tie it together in a second. So we're going to take that transaction data. So in that dictionary that we're going to get, the transaction data, we're going to go down the tree. There should be something called transaction, and you can figure this out by going to the website. Again, you can go down here and figure out what's in the tree. Transaction, there's message, there's account keys under that. So that's all I'm doing. I'm just going down that tree. Now there's something wrong with the JSON data. You'll probably get some errors here, but we're assuming that the RPC is passing back good JSON. So what I'm looking for here is message, and then under that would be account keys. A good step to take is to actually debug this while you're doing it. Do some unit testings while you're developing it. Since I've already done this before, I already know this is gonna work, but this just can be a pain point. If you don't get these names right, you know, even if one letter is off, it won't work. And it's ideal to just create some unit tests, debug this part first before trying to test do your entire system test. So the next thing we want pre-sold balances. We want our pre-sold balances, and I'm just gonna cut and paste this. I'm gonna cut and paste this stuff. We want pre-sold balances. We want our post-sold balances. We want our pre-token balances, and then we want our post-token balances. I'm not gonna type all that in. I have it already pre-made. pretty easy to understand. So these are all the paths to getting that information. Okay, does that make sense? Hopefully that makes sense. And the next thing we want to do is we want to create an object for us to hold this information for us, because this is one we want to pass back. This is what we want to return. So I'm going to create something called swap transaction info that takes in 0 inputs to the constructor. So we're going to create this swap transaction info. Let's just continue though. So let's check to see first if the number of accounts is equal to the SOL balance number of or the number of elements in the SOL balances array. This is sort of for robustness, just to make sure. Let me call this accounts. Yeah, this is a robustness check just to make sure that the JSON data is formatted correctly. It's good JSON data, so it's one check measure you could do. So I'm going to check against the pre-SOL balances array, and I want to check to see if the post-SOL balances array is also. I'm going to just cut and paste that. I'm going to check the post-SOL balances array is also that size. So when you do len on the array, it'll just pass back the size of that array. So if it contains 5 elements, 5 accounts, then it will pass back 5. So this SOL balances array should be the same size if this is a good response. So we'll say account is found. We'll create a little flag here called accounts, whether the account was found. Just set that to false initially. Here's the theory behind what we're trying to do. We're trying to see if we can find this account, the owner address account. So we want to see if it's available in this transaction. So that's what this is doing. All right, so we want to create a for loop here for I in range and on the length of the accounts. Actually, what I can do here, let me create a little convenience thing here so this doesn't get too confusing. Number of accounts, and I'll initialize that to the length of accounts. Okay, and then I will replace this here, accounts. So we want to do an in range. We're going to cycle through all of the accounts until we find what we're looking for. So if the owner address equals accounts, we're going to iterate on the accounts, right? So to access an element in the accounts, we'll use the index I. Under that is going to be something called the pub key of that account. So you can make more sense of it if you look in this response. So this would be element 0, 1, 2. So that's all it's doing. It's cycling through these. So if one of these matches what we're looking for, then we'll go ahead and kick out of this, remove this. All right, so continuing on. So we get that check in. We're gonna go ahead and initialize some of our transaction info, and we're gonna have something called payer address. We're gonna equal that to the owner address, number 1. Transaction info, we're gonna also initialize something called the SOL difference. What we want to do is we want to take our post SOL balances for that same index, and then we're gonna subtract that by our pre-SOL balances. Kind of paste call this pre-SOL balances. So just to explain, your post-SOL balances are what you have after the transaction goes through. So if you bought some token, you'll have your SOL balance will be different, right? Your SOL balance would be less than your pre-balance. If you sold a token, your SOL balance would be higher than the pre-balance. So that's all we're doing. We're checking the difference here. So if you bought some token, your post balance will be your difference would be negative, and if it's the other way around, your difference should be positive because you gain SOL. Okay, so we'll go ahead and initialize this account found here to true. If this happens, then we don't need to run this for loop anymore. We can just break out of this. So we call break, so that will kick us out. So it'll keep on running until it finds it. If it's not there, if the client entered in a bad owner address, then it will not. It'll run through the entire number of accounts and it won't find anything. It'll just kick back none. So let's just assume that we did find an account. So we'll create something down here. We'll check for that if account was found. Let's do it again. Let's reuse this accounts found flag because we're going to check something else. We're going to make account found false, and we're going to find the pre-token balances. This is a little more complicated than getting the post token or the SOL balances, because the SOL balances were just numbers, right? Well, you get a little more information in the JSON for the token balances, and I'll show you that. So we're going to create something for us called extract token balance. So we'll create this in a second. I'm going to call this underscore extract token balance. I'm prefacing it with an underscore because this is just an internal method. I don't want anything else outside of here to really use it. That's just a way to categorize things. Let's see. We want to pass in our pre-token balances. So that's what we parsed from our JSON. So if you were to debug this, you would see what this is, what this contains. It's not just a simple array of numbers. It's got a lot more stuff in it. So that's why I'm going to create a utility function to parse that data that we need out. And then we want to do the same thing for our post token balance, but we want to pass in our post token address balances in there. And I'm going to just cut and paste this part. So assuming that we extracted our token balance information, it's going to pass this function is going to pass back some more JSON for us, but it's going to be just a subset of the transaction data. So we're going to get our pre-token amount. So based on this, what we get back here, we're going to parse our UI token amount and then our UI amount. This is going to give us our token amount, and it's an unscaled token amount. It's going to give us the actual token amount that you see on your wallet. So if you have 1,000 tokens, it'll say 1,000.0. That's what this UI amount is. So the next thing I want to get the token count index, and I'm gonna of our post token balance. I'm gonna get our token account index of that. I'm also going to initialize our transaction signature. Yeah, let's go ahead and parse the transaction signature, because this is parsing this transaction. It has no idea what the signature is unless it parses the transaction signature inside of this transaction. So how do we get that? Okay, let me put this down here because it doesn't make sense yet why we need that. But we're just initializing our transaction info, so we provide as much information to the client as we can. The next thing we want is we want to initialize our token address, and that would be the mint or the token address. So we bought dog with fat, that would be the mint address for that, or token address for that. And this is where we need the account index. So in order to pull the paired token account address, we need the token account index. So I don't know if I explained it, but when you buy a new token, there is a new account that's created for you. It's a token account. So basically a token account will be created for each new token that you buy. So that's all we're getting. We want to get that token account information. We want to put that information in here. This will be important in the future. So we're going to initialize the token, something called the paired token account address, and we're going to initialize it to the account token index pub key. And we also want to keep track of the token amount or the token balance. So we'll go ahead and initialize that. So we know that the paired token balance will be the same as the post for this owner. And then we're going to calculate the token difference, just like we did with SOL difference. We want to take the post and pre-token amounts, subtract them, and that's what I'm doing there. And from there, we'll just go ahead and return our transaction info. So I know this might be a little confusing, but we're just going down trees and stuff like that and trying to correlate what accounts belong to the owner, and we're grabbing the information out of that from there. So just spend some time trying to understand this if you really want to. Otherwise, just trust it that this is what we need. So going back through here, we need to initialize a few things, or we need to create a few things like the swap transaction info. We'll go ahead and do that now. I'll just go ahead and put this class into this one. So we could put this in a separate file, but I'm just gonna leave it here for now. So I created this thing called swap transaction info, and basically it's got everything we need, right? It's got our signature, token address, payer token account address, payer token balance, SOL difference, token difference. Okay, and I provided a function to print out the swap info. You don't really need to do this, but I put this in here for like diagnostics. So this is just a convenient way to print this out. We'll take our SOL amount. We'll take our SOL difference, which would be in LAM ports. I'm assuming this will be in LAM ports. It's just easier to work with. And I'll divide that by 1 to the 9th, which should give us basically the UI amount of SOL, like your real amount. So if you got 1 SOL worth, then it'll print out 1. Token amount, print out the difference there. We should have the UI amount of tokens in there. And we'll go ahead, and if the SOL difference is negative, basically that's what this check is doing. It's going to print out that the payer bought this amount of tokens for this amount of SOL, and if the SOL difference is greater than 0, greater or equal to 0, then the payer address sold this amount or sold this token amount for this SOL amount. So it's just a convenient way to print the swap info out, and we'll use it in a second here. So we got that. The next thing we want to do is we want to implement this extract token balance, and let's do that right now. So we're going to create a new function called extract token balance. I got the signature here. Let's create that. And what we're going to do is what gets passed in is going to be a dictionary. So we're going to iterate on this thing called token balance. And in the token balance dictionary, it's going to be pretty simple, really. So if the owner address is equal to the token balance, and we're going to look at the owner, we're going to look at the owner tag of this dictionary, then go ahead and return the token balance. We're done here if that's the case. That's it. That's all I'm trying to do, is I'm trying to extract the token balance that belongs to this owner. That's it. So again, you can go through the API to look to see what I'm trying to do, what information I'm extracting here. And it's still giving me an error here. What we have to do is we could either make this static method of this class. We could do that, or we can put it outside the class. However you want to do it, it doesn't matter. I'll go ahead and just do static method. So we don't need to put self here because it's a method that could be called without the class being initialized. But if I do that, I have to actually use the name. I have to do that. SolanaRpc. We should be good to go there. So you probably want to do some testing right now. This is a lot of trying to find certain patterns and paths in the JSON. So there's a lot that can go wrong here. Like I said, if you have one thing that's wrong in here, it won't work. So it's a good idea. You'll probably have to spend some time debugging this. Of course, if you use the code that I provide, it'll work. Back out. So I think that's good. So now let's go back to our trades manager, or let's go back to main. We should be good to go. We have our parse swap transaction. We have our get transaction done. So if that works okay, then one thing in our function for parsing the transaction, let's go back in our SolanaRpcApi. You got to make this a static method. So we're using this swap info method, so we just need to make sure that is a static method there. All right, we got something. So now it's probably going to check to see if this transaction is on the chain. All right, so there we go. All right, so it looks like we were successful. I got everything initialized: payer address, token address, payer token balance, or SOL difference in LAM ports, the change in there. Token difference, I got 13. Now you can go in your wallet and confirm all this information, or you can take the signature, just copy that, and put it into SolScan. Let's go to SolScan and go ahead and just paste that information without the quotations on it. SolScan's having issues. All right, so there you go. That was our swap, and you can verify that Sol balance changes 0.0011 Sol. Well, we had it in Lamports. That looked about right, and it tells you the token differences, token balance change. So this is my wallet, right? So this is the amount that got transferred to my wallet, 13.13. Let's see if it matches 13.13. See? Token difference, the Sol difference in Lamports, negative because I bought. So it's all in there. Looks like it worked. So let's go down further. It's gonna print. Okay. This makes it a lot easier to read. My address bought 13 tokens, 13.13, blah, blah, blah. Tokens for 0.001105 Sol. So that's correct. So let's go a step further and just go ahead and sell back what we bought just to demonstrate that. So I'll go and stop this, and I'll just go ahead and do it again. So I'm dealing with very small amounts here, so it doesn't matter. I'm going to go on and buy again and go and sell back everything that I got. Okay, so what I'm going to do is I'm going to create this loop again. So if it kicked out of here, that means that we did succeed. It's just going to keep on trying forever. So we can adjust that. We can actually put a max number of tries on this if we want. This is just for testing, so it doesn't matter. But anyway, let's just assume we kick out of there and we did succeed. Now we can assume we're gonna set did succeed to false again. And we'll rerun the loop, and we'll go ahead and set the something called the sell amount. So now we're gonna calculate the amount that we want to sell. We're gonna use transaction info here. So let's just break this down a little bit. So our transaction info, we're going to take our token balance and multiply it by 1 e to the 6. This is because we want to take out the decimal points. So for this particular token that I'm trading, it's got 6 decimal places. So I want to take those out. I just want to turn this in a whole number basically. So that is what most of the APIs take. You can't just pass in the UI amount. You got to scale it. To do this right, you have to know the number of decimal places. For pump fund tokens and most tokens, it's usually 1 e to the 6, but it could vary. So we have that information off the token info, but don't worry about that right now. We'll deal with those kinds of variances later. So just assume that this has 6 decimal places. So we're going to take that token balance and convert that into a whole number. We're going to create the sell amount from that, and we're just going to do the same thing we did up top. We could create a little function that does this whole thing for us if we wanted to reuse it, but this is just for testing, so it's a throwaway code kind of. So this is just to demonstrate the buy and sell. So we're going to go ahead and pretty much just cut and paste all this stuff. It's going to be pretty similar. Instead of buy, we're going to put in sell. And what are we going to sell? Well, we're going to sell that token. Token address stays the same. Buy amount. Instead of that, do that. We'll use the same slippage. Actually, it looks like I'm just using the free plan Helios. I'm not right now. I don't have access to a private node right now. They're expensive. You either have to host them yourself, which is expensive, or you buy a premium node, or you can rent a premium node. They cost quite a bit of money, so I don't have that going right now. In the bonus material, I will show you that. I'll show you the difference there between having a premium node and a regular node. I'll do a benchmark test, but not in this video. All right, so let's set our slippage a little higher. I'll set it to 50% here, just so it'll be more likely that our transactions will go through faster that way. And what are we going to try to do? Just for efficiency's sake, this is kind of bugging me. This code is pretty much the same across the board. Let's create a little function outside of here that does this stuff for us. So we'll create a little function called def make trade, and we'll just have a flag in here is buy. This will just be a boolean. We're gonna have to pass in a few things as well. Let me just check that. If is buy, we're gonna pass in the trades manager. We're gonna pass in the amount, as an int. So yeah, so if it's a buy, then we'll pass in the amount. We'll call buy. We'll also pass in the token address. We'll also pass in the slippage. And yeah, there we go. And I'm going to take out this indent here. We also need the market manager. Kind of paste that. We'll need this loop here. We're gonna keep on trying forever. We'll just do it that way for now. And we need the did succeed flag here. And you can do whatever you want here. I mean, this is just for debugging purposes, troubleshooting. You could have a timeout, max tries, all that if you wanted to. So we'll call make trade. We'll pass in our market manager. We'll pass in our trades manager. We'll pass in the token, the user input as the token address. We'll pass in the buy amount. We'll pass in the slippage. And this, since this is a buy, we'll say true on that. And just I'll put in a comment here buy. Now we don't need all this. I'm gonna take all that stuff out. I do want to create the sell amount. We want to make this, if it succeeded, a transaction info, we'll go ahead and return it. Alright, so we're done once it does that. And by the way, there's something wrong here. So I gotta take that out. I gotta do the else here. Else, if it's a sell, and go ahead and make this signature, do a sell. That's it. So if it got a signature, go ahead and make succeed true. Then it'll kick out of this loop. And just to be clean here, I just want to use good practices. I'm gonna set that to none, and I'm going to return that at the end. So since we're setting did succeed to true, this while loop will stop, and then we'll go and just return that. That's just cleaner looking. So we'll set this to make trade, and we'll get that transaction info. Let's double check that we got transaction info. So if we did, we'll go ahead and make a sell. We'll make that sell amount. We'll grab the payer token balance and multiply that by 1e to the 6 to get rid of the decimal places. Make that a whole number. We don't need that. And we'll do the same thing. We'll get a new transaction info. We'll make the trade. We'll use the same token address, but then we'll pass in the sell amount, and we'll pass in false here. Is buy? No, it's not a buy. It's a sell. So let's go on and test. We should have what we need to do this. So it's gonna attempt to go ahead and sell it now. So that's what it's doing right here. And I received a response. So we potentially did our sale, and I did not. Unfortunately, I didn't print out the signature for this. Oh, but I can look at my wallet. Let's go ahead and check the Sol scan for this transaction that just occurred. I think something went wrong. We're gonna print out buy that we're buying here. Buying tokens just to get a feel for where we're at. Selling tokens. We get rid of that comment. Selling tokens. So debugging this again. So we're gonna put in our token amount, our token address. Alright, so I got a response. Now it's going to check to see if that transaction is on the chain. It's gonna wait a little bit. Okay, so we got something. Let's see what we got. Yeah, we got our stuff filled out. I'm assuming that's correct. Let's see what the sell amount is going to be. So we're gonna sell all of our token amount. This is the amount of tokens that we have. And I already see an issue here. It's not going to sell. I need to cast this to an integer. So this has to be an integer. It can't be a floating point number. So just understand that. So let's do this again. All right, so I got a response. So it should be trying to sell after it confirms the token or the transaction on the blockchain. Okay, I got it. So now it should be trying to sell. So I received a response. We should be good. It says right here, I think that's incorrect. It says that I bought tokens for that. So let's go back to RPC API. All right, so I think I made an expensive mistake. So let's go into our sell function. So I don't think it's selling. So we'll go in our self function and verify something. So it's so similar to buy. It's using the swap function internally. So as I thought, these inputs are backwards. So the swap function takes in this input. The first input is what we're swapping with. So in here, this indicates that we're swapping Sol for this token. We just need to reverse this. We want to swap the token address, or we want to swap this token for Sol. So that's all. That's all we got to do. So let's go ahead and rerun a test. We'll start from scratch. The token address, so give it some time to buy. All right, so it succeeded on the buy. So we got a notification. So it's probably checking to see if that transaction is on the chain. That'll take a little bit. I got an error. All right, so let's fix this. This is a problem if you buy a brand new token. So I'm taking post token amount minus the pre-token amount. So likely, since the token account did not exist before, there's no pre-token amount. So let me just account for that. So it's very simple really. So if we have a pre-token amount, we'll go ahead and do that. Else, we'll just go ahead and do this. We'll just set it to the post token amount. So we're guaranteed to have a post token amount. We may not have a pre-token amount because the payer may not have that token yet. That should take care of that. Let's go ahead and retry. Let's go back to main and retest. All right, so we got a response. We bought. So now it's going to check the transaction on the chain. That could take a little while. All right, so I got it. So I bought 14 tokens for that much Sol. So it's going to try to sell that. All right, so finally it sold it. And you gotta, yeah, try to do it again. For some reason it didn't catch it the first time. And there's an instruction error. Let me go ahead and stop it. So I need to tweak this up. If you're dealing with a good RPC node, you shouldn't really run into these issues. But if you're using free plan RPC nodes or slower non-premium RPC nodes, you may have to do some of these things to get it to work. So I've never really ran into this issue in the past, but here's how to deal with it. And we're just making the code more robust to handle this type of situation. So what I found is if we go into our Solana RPC send transaction, remember we set the max tries thing. So here's some tweaks I made to this. I'm skipping the pre-flight check because that seems to make things go slower. So the RPC has to do a pre-flight. If you have this skip pre-flight to false, or you don't have it set at all, we didn't have it set at all, right? We were checking pre-flight. I thought that was a good idea because if we have a bad transaction and it fails, then we would get charged a gas fee for that. Well, it turns out that the RPC node struggles on this a little bit and slows things down, so your transaction may not go through because of that. So to speed things up, we'll go ahead and skip that pre-flight check. So just know that the risk here is that your transaction might fail for whatever reason. It could be slippage, it's not high enough, and you would get charged a gas fee for that. So that's take precaution with that. So with that, I could comment out the pre-flight commitment. We don't need that anymore. This max retries, let's go back to the calling. We're going to go ahead and set that actually. We're going to let the RPC node handle the retry of the RPC call. What we're going to do is we're going to try 10 times. We're going to ask it to try 10 times. Before we were trying to manage that, and that mechanism didn't seem to work really well. So we were waiting 5 seconds for a response on the WebSocket, and for some reason that it did not work out so well. We would resend every time we check, every time we got a failed check. But let's go ahead and comment it out. This code, just let the RPC node handle it this time. Also, I moved this code. This was in the exception. I moved this out of here. So what I'm doing here is I'm checking to see if we do have a transaction checker, and I'm waiting. I'll wait the whole 35 seconds to see if we do get a response back. If not, it's rep file will be none, and that'll mean that we did not get a response. So that'll tell the client, okay, I need to retry. Well, let's go ahead and retry this code. So it's spamming the RPC, and now I got a response back. I'm getting much better results doing it this way. So that means a buy went through. So now it's checking to see the transaction on the chain. All right, so now I got it. It did a successful buy. Now it's going ahead and doing the sell. All right, so let's there's an error here. I believe it's because we sold all the tokens that we have. So we're gonna go ahead and check to see if we have a pre and post token amount. So if we do, we'll go ahead and just subtract post token amount. We'll do some other checks here. LF, we have our pre token amount. That means if it got over here, that means it does not have a post token amount, which means the post token amount's likely 0. So we'll just go ahead and make the token difference what the pre-token amount was. We'll make it, the difference would be that we have a 0. Basically, we have a 0 post-token amount, so it would be post-token amount 0 minus pre-token amount. But and then if else, that means that we have a post-token amount, so our post-token amount difference would be just our post-token amount. Okay. That should take care of any errors there. So let's go ahead and rerun. Right now I have 0 tokens available of this one I was testing with. So let's go ahead and try to repurchase. Let's run that again. Let's fine tune some more things in here. So in our SolanaRpcApi, in our transaction checker, on our check for did succeed, we check to see if there's if error is none. Let's just keep that out for now. Let's just assume if we get a response and it's true, we'll leave it up to the client to double check that the transaction is valid. Because what's happening right now is it looks like sometimes the responses don't come through. Maybe they take longer than 35 seconds and we got a timeout of 35 seconds. Maybe they're coming through after that. So what is happening is that it's retrying to send the transaction and then now it's getting an error. Since I disabled the pre-flight checks, it's the transaction is failing now because I'm trying to sell tokens that I don't have anymore. We do get a response from that and it's an error. Right now, I just want to make it so that if we get a response, just return true that we did succeed so that we don't continue trying to resend the transaction. Up in main, since we're actually checking the transaction on the chain once we make the trade, so we created this little function here. We're actually getting that swap info from the chain. So we can make it up to the client to kind of handle that situation. Like I said before, if you're using a high quality RPC node, you probably won't be running into these issues, but we should make this code robust enough to handle any RPC node. So let's retest this. All right, so we got a response right away. We bought tokens. Now it's going to get that transaction off the chain. So we bought 13 tokens. So it's going to try to sell them. See how long it takes. So like I said, in the bonus material, I'll be going over using a quality RPC node. I'll show you the difference there. They are costly, so I don't have one reserved right now. You can either host them at home, but you need the bandwidth. You need a high-speed internet connection, at least 1 gig upload speed. And then you're going to need some pretty good hardware to run the RPC node. It's upwards of 15 grand to purchase that hardware to host that server yourself, so it's not cheap. But if you're serious about this stuff, it's going to be worth it. Honestly, myself, what I've done in the past is I've rented out my own servers and set up my own RPC nodes on those servers, but they do charge monthly fees for that sort of service. The other thing we could do is we could purchase a premium node. We can rent a node from a provider, and it's typically not cheap, but we'll get into that in the bonus material of what your options are. All right, so we finally received a response. It took a little while, and we're good to go. One thing I want to do here is I'm going to increase the time on the checker. I have a feeling that sometimes it's timing out. I'll give it a minute. How about that instead? But it looks like we sold all of our tokens, and we can double check the transaction. Let me go and check my account. Let's check my transactions. All right, so you can see that the last 2 are the ones we care about. This one would be the buy. So I swapped some Sol for 13.2 tokens of Sydney, and then the next transaction I swapped 13.2 tokens for my Sol back. So it worked. and it tells you what the slippage is and everything. So with that, I think that concludes the demonstration. I showed you how to do buys and sells using the Jupyter API to create the transaction. We did some tweaks to get things to work. It was a little rough at the end, but we got it all working. So like I said, most of the challenges that we're using the free plan Helios plan, I was trying to use some other RPC nodes to see if I could get better results. But anyway, we made the code more robust to handle those types of situations to get our transactions through. So with that, I'll bid you guys adieu, and I will see you on the next one.